Hi there, I'm again back and I'm here with one more question related to the CSIR-NET. And this question is also related to the Cauchy's integral theorem and formula. The question that appears before the screen is, let gamma t is equals to 3 e to the it, where t is taking the values between 0 and 2 pi. And gamma t is a positively oriented circle of radius 3 centered at the origin. The value of lambda for which integral over gamma lambda by z minus 2 dz is equals to integral over gamma 1 over z square minus phi z plus 4 dz is. The option given for us is lambda equals to minus 1 by 3, lambda equals to 0, lambda equals to 1 by 3, and lambda equals to 1. Now, to solve this question, as I told you in my previous class, we should have a little bit idea on Cauchy's integral theorem, as well as Cauchy's integral formula for simply connected domain and multiply connected domain. Now, according to this question here, we see that we can apply the Cauchy's integral formula to solve this problem. Now, the given problem is integral over gamma lambda by z minus 2 dz is equals to integral over gamma 1 over z squared minus 5z plus 4 dz. Now, what we are supposed to do is that we have to factorize this denominator. Upon factorization, we can see that integral over gamma 1 over z minus 4 into z minus 1 dz is that we obtain. And the given circle for us is that C is mod Z is equals to 3. That is, the circle is having its center at the origin and radius of 3 units. And if at all we are intending to draw the circle, you can see that it's something looks like this. So here is the origin. This is the origin. Of and the radius of how many units? Radius is the center. This is the center. Center is at the origin. And radius of how many? 3 units. So this is from here to here 1 unit. This is second unit. And this is the third unit. So likewise, we draw to the left side up and also onto the bottom. Also, we try to locate all the 3 units point and then we try to draw the circle. And if we get back to this question, and here we see that the after factorization, we obtain z square minus 5z plus 4 is equals to z minus 4 into z minus 1. And this actually gives us the singularities. And we can see that the singularities or the poles that we have, the singularities are the poles here. And we have got 2 poles. One is with the simple pole and the other one is also a simple pole. Z equals to 4 and the other one is Z equals to 1 and both of them are simple pole. Now, if we try to locate these poles into the circle, you see that 4 is somewhere outside here. This is the 4 and this 4 is lying outside the circle. Whereas when you see Z is equals to 1, you can see that Z equals to 1 is inside somewhere here, inside the circle. And so therefore, what we can do is that we can apply Cauchy's integral formula very easily. Now, according to the Cauchy's integral formula, integral over gamma fz by z minus a dz is equals to 2 pi I into f of a. So whatever the a you have, the pole that you have located, the one that is lying inside the circle, the closed contour, right? That pole is this a, you're going to make the substitution in your f of a, right? So therefore, we have integral over gamma lambda over z minus 2 dz is equals to integral over gamma 1 over z minus 4 into z minus 1 dz. Now we are supposed to figure out our f of z perfectly. Now that this z minus 4 or you can say that z equals to 4 is outside the circle. Z equals to 4 is outside the circle. So therefore, what we try to do is that we try to take the whole of this factor as our f of z, right? So what happens is that this becomes integral over gamma 1 over z minus 4 by z minus 1. And since that z minus 1 is inside the circle, we take it into the denominator. Now we try to apply the formula. According to the formula, This integral over gamma fz over z minus a into dz is equals to 2 pi I into f of e. Now here we apply it for the both. So for when we apply it to the left-hand side, you see that it is 2 pi I, and here for the left-hand side, your a is equals to 2. And when we check out to the right-hand side, we see that for us, a is equals to 1. So this is 2 pi I into f of 2. This is equals to 2 pi I into f of 1. Now, this f of 2, your f of, this is only your f of z that you have is lambda. So we try to substitute the same thing here. So lambda is equals to, and towards the right-hand side, you see that the whole f of z is 1 by z minus 4. So wherever you have the z, you're going to substitute it as equals to 1 over here. So this is 1 by 1 minus 4. Lambda is equals to 1 by 1 minus 4. And upon calculation, you can see that z is equals to minus 1 by 3. Hence, when we go back to the options, we can simply see that lambda is equals to minus 1 by 3. That is option A is the right answer. So this was the question that we were supposed to solve for today. And that's all for now. Thank you. Thank you so much. And I wish those who are watching this video try to like it and also subscribe my channel. Thank you.